We're going to talk a lot about Gen AI today, but I'm going to start by just giving you some foundational background on Enterprise Web, just so you could sort of place us as a product, since some of you on the line have never heard of us before. So Enterprise Web, if I was going to put ourselves in a Gartner category, put ourselves in a box, we'd be an AI-enabled no-code platform. Now, of course, as many of you know, there's probably hundreds, if not thousands, of companies now that now claim that. The real different, historically, no-code platform means citizen developer, simple applications, things that ultimately end up becoming complicated because they need IT to do anything that's like back-end integration and et cetera. Any complex functions, et cetera, end up being with IT anyway, which makes you wonder why you bought a no-code platform. Enterprise Web is an AI-enabled no-code platform for distributed systems engineers, for data scientists, for solution architects. We do hardcore stuff and across a variety of industries. And so Enterprise Web is all about using real-time information for intelligent business and infrastructure applications. And as that little graph icon sort of suggests, Enterprise Web is effectively a knowledge-driven orchestrator. We're leveraging a hypergraph. So a hypergraph is a different kind of graph technology. Most people are familiar with things like semantic web and maybe Tiger Graph or Neo4j, but those are really just graph databases. They're graph databases for data science, data analytics, and data recommendations. That's its niche. What it can't do, it can't do complex real-time operational behavior. In Enterprise Web's graph, it's partially because those kind of graphs, RDF type graphs and labeled property graphs, are essentially two-dimensional. They're based on relationships between data and data entities. Enterprise Web's graph can include policies, it can include functions, it can include contracts. So it's a rich contract graph that's able to model an enterprise's operations. And so we use that graph to interpret events, automate decisions, and optimize actions. Everything binds in real time. So it's a fully event-driven platform, event-driven, async, concurrent, massively parallel. Again, we're doing things in telecom, millisecond speed, standing up mobile networks, right? So we do advanced industrial grade automation. So the thing, if you look about the kind of things that are happening in Gen AI, early Gen AI, it's mostly experimental, right? Or it's customer service or things like that. But people are waiting for the other shoe to drop. People are aspirationally looking for like, hey, when am I going to do like real world mission critical, automation? Enterprise Web is already doing that. We've won awards with Microsoft. Microsoft identified us as an automation platform, and last May, over a year ago, we demonstrated premiered the world's first telco-grade generative AI for service orchestration, working with Microsoft leadership. So we have 21 awarded U.S. patents. They're all around pretty arcane computer science ideas with hypergraphs and metaprogramming. But the whole idea is making things simple is actually really complex, right? Your businesses are all very complex operations. They're all very dynamic. They're changing all the time. The elements of your solutions are changing all the time. Making that simple for your developers, improving the experiences for your customers, that takes a lot under the hood to sort of hide that complexity. So our thesis is that businesses need an enterprise web. You need like an umbrella abstraction. As a business guy, you'd like to look down on your network and you'd like to see your people, your information, your capabilities, and you'd like to be able to flexibly compose them for purpose. You don't want to be told by the business what you can't do, right? And when you ask IT to develop an app for you, you don't say hard code that in stone so I can never change it again, or it's super expensive. You'd like to think that your things are all done in sort of metadata and that they're agile and that you could update them really quickly because you can anticipate that the elements of your solutions are constantly changing. So you need a very flexible, extensible graph that allows for that. So, Enterprise Web's really using that graph for an abstraction as a single source of truth for the design, deployment, and management of complex distributed systems. And essentially in 2024, every business that's running in the cloud is a complex distributed system, right? So the graph knowledge base is not only just, a lot of folks here, I think today have been talking about the data side. we're not just talking about the domain semantics and the data. We're talking about state information, right? We're talking about properties, behaviors, telemetry, right? We're talking about things that we can actually take action on, real-time contextual action. And we're using that for intelligent orchestration, configuration, workflow automation, and policy-based management. You're going to see all of these in the demo. So the platform is essentially providing an enterprise web. You think of it as a unified interface over your enterprise. It presents a centralized catalog of all your solution elements, a design environment, common tools for IT, collaboration and productivity. And if you were to look at enterprise web and just based on that description, for those of you who are familiar on the app dev side, you might call this like a cloud IDE, an integrated design environment. You could see there's things like design, composition, object modeling. There's things that look like middleware functions that you might expect in a middleware stack. What's really cool about this, Enterprise Web has nothing but the graph. The execution environment, the design environment, the object modeling environment, those are just projections from the graph. All these platform services are declarative expressions that live inside the graph. In other words, there's no middleware stack in Enterprise Web. These are all stateless serverless functions in Enterprise Web. So that the functions are living co-resident with the data. And that gives us some very powerful capabilities. That means that code can reason over data and data can configure code in real-time pipelines. This is actually a modern implementation of what actually was implemented in mainframes 30, 40 years ago, right? In mainframes, you had all data and code lived together as zeros and ones with addresses. And the reason the mainframe was so powerful is because the data and the code were co-resident and they could actually reason over each other and work with each other in ways that were very, very, very powerful. Enterprise Web is bringing that in a modern cloud native a solution in 50 megabytes. So you might think of the graph as sort of like a DSL, right? And this graph includes an upper ontology. The upper ontology is complete with like generic business concepts. We know what people are. We know what organizational units are. We know what permissions are. We know what facilities are, et cetera. But we also have a rich type system, right? We know what protocols, formats, types are, right? We know what schemas are. We know what AWS looks like. We know what Azure endpoints look like. We know what AWS endpoints look like. So we have a rich model of distributed systems and a rich model of the enterprise, and then we can sort of plug in customer information, customer domain information, and plug in their objects and make that all highly composable and dynamic. The way Enterprise Web actually implements behind the scenes, which makes it really complementary to modern AI, is Enterprise Web is actually agent-based. So our runtime is based on agents. Our graph is this hypergraph I told you about, and our functions are all stateless functions. So this entire environment is 50 megabytes. That includes the customer domain model. 50 megabytes that requires no third-party queues, gateways, brokers, integration tools, orchestration engines, etc. No middleware stack. Completely horizontal architecture, elastically scalable, can deploy at the core, can deploy at the edge, can deploy on a laptop, can deploy on a device, deploys in minutes. Enterprise web nodes can connect each other in an application fabric, so we can actually connect ourselves, and Enterprise Web itself can be distributed. So a lot of advantageous features. So as I said, Microsoft identified us, and we did this award-winning project with them, which was telco-grade service orchestration. Essentially, what we're showing is how we're showing enterprise-grade generative AI, right? I heard somebody talk about non-functional concerns earlier, right? It's not just about doing things contextually. What about security identity? What about reliable messaging? What about transaction guarantees? What about state management? I haven't worked with an enterprise where those things aren't important, if not critical to their operations, and consistency and safety and all those things like that. Enterprise Web is bringing those attributes to Gen AI to provide transformative customer developer experiences. We're already simplifying and automating service design, deployment, and management. we're improving code summarization, analysis, and recommendations, and we're enabling developers to incorporate Gen AI capabilities into their business apps so that their customers can enjoy natural language interfaces and contextual automation. So the whole point here is to streamline the integration, use, and management of LLMs, get rid of the static RAG pipelines, get rid of custom Python code, get rid of manual integration. I mean, if you guys look at what people are building, the flimsy scaffolding that people are building around Gen AI, you have the state of the art of deep learning that's running on nuclear power, and people are doing manual custom one-off scripts to run it. I mean, it's actually sort of ludicrous. So we're just saying you want to do this with a platform-based workflow. So businesses need practical enterprise-grade capabilities, and you also have to mitigate those weaknesses of Gen AI, right? You want to isolate and contain LLMs. I wouldn't want any LLM, directly touching my mission-critical automation. I don't want those hallucinations creeping back. I don't want it to have access to my IP and et cetera. So Enterprise Web is shifting processing away from the LLM running on GPUs to web running on CPUs. And our graph is essentially providing the context so we can ground LLM interactions in knowledge, in domain knowledge, so we can optimize those outputs and then drive that to automation. So we optimize the LLM outputs with our graph, and then we could translate interactions into actions. So the first use case that we're going to demo, we're going to switch right to that demo after this statement, is we're going to show you how we can use generative AI to simplify and automate complex integration and transformation tasks. So I'm sure a lot of you are going to be familiar with like old-fashioned EAI and ETL, right? And people still do this manually, right? And you got development departments. Some of the biggest corporations are doing, coding and recoding, integrating and recoding these crazy stacks like continuously. It's like running uphill for the rest of their lives, right? They never get better for having done it before. So here we're able to show how you can actually use our platform, use Gen AI. A developer can actually talk to Enterprise Web, say, I want to connect these Enterprise Web systems with these SaaS apps, and generate the interfaces and generate the ETL workflow and implement that for me. And literally, Bill's going to show you, my colleague is going to show you it's that easy. It takes like just a few minutes. So Bill, I'm going to stop sharing and let you do that one, and then please take that away, and then we'll do the next use case. And I can see you, and I'll tell you if I can't see your screen. Yeah, I can see your screen now.
Yeah. Okay, perfect. All right, thanks everybody. So given the short amount of time, I'm just going to concentrate on how easy we were able to make this for a developer. We can always dive into details later. So I'm going to get right to it. I log into our system, and what you find right away is going to be a catalog of all of the already onboarded endpoints, services, etc. Basically, the enterprise systems and the cloud-based apps that we're going to be integrating. In the next couple of minutes, what you're going to see me do is onboard another one using Gen AI. Then I'm going to compose that ETL pipeline using Gen AI, and you're going to see that all the integrations and ETL workflows are going to be automatically generated for me and implemented, and I'm going to do it in just a couple of minutes. So let's get started here. Onboard a new endpoint called Salesforce from a Swagger file. So I find that Swagger file, upload it, and the system automatically compares it to that graph, scores it as being an ERP or CRM endpoint that basically that's what the APIs are pointing to. You can see there's a number of them that come out of the graph. Once I confirm that, it's going to map all the details and generate interfaces for this endpoint.
Please use the report shown to fix the errors found during import.
So Gen AI is actually directing me to fix this, whatever changes need to be made to get this onboarded and validated in our system, basically so that you can benefit from that effectively no-code integration. So it's telling me here how to fix it. But if I just take a quick look at what was done, the system's actually gone in and it's mapped it to a number of application models it recognizes, so it knows there's going to be customers, products, etc. It understands things like the data formats and so on that are going to be over top of this. It went into a low level and actually took the object mapping, and in that short amount of time, it did a very low level mapping of literally everything that you find inside the API. For instance, an object ID maps to our org ID, etc. It does all the matching there. It gives you confidence intervals. And as a developer, you can go in and, you can go through these as much as you want, but it does a good job out of the gate. And it goes on literally forever. There's hundreds of attributes that it mapped in that under a second. The one problem that it had and it identified at the beginning was that it couldn't choose between whether this was referring to an offering or a product. So I just make my selection here. You can see it's already passed, and basically that was all the work I actually had to do to onboard this particular endpoint for Salesforce. I can also look, though, it generated a set of interfaces and all that kind of good stuff, and it even built a graph representation for me. So it shows me how this thing mapped to the graph. This is what is enabling that no-code integration. It actually is able to determine, okay, there's going to be common models for most CRM systems for particular objects. They come in a certain data format, and this is going to enable the system to map these payloads intelligently to effectively any kind of ETL pipeline I might want to build, or any automation that I might want to build over top of that. So that was pretty quick, but I'm going to basically what I'm going to do now is just send this thing for testing. So everything in the system has to be tested, all that kind of good stuff. We're enforcing things like DevSecOps pipelines and best practices. And right now, it's actually standing up an instance of our system, and it's doing verification of the endpoints and reachability checks and so on. This will be finished in a few seconds from now, and then we'll be able to actually start composing
The endpoint has been published to the catalog.
There you go. Thanks. So the GenAI just told us that. So now it's in our catalog. So just like that, we actually have a source. You can see it's added to the list, and you can add as many of these as you might want, all nice and easy. So now what I'm going to do is I'm going to compose it using GenAI. So this is the sort of payoff. Show me a list of service templates.
Working on it.
Show me the graph of an ETL pipeline.
Working on it.
Add all CRM systems as sources.
Working on it.
Add a Snowflake database as a source of customer data.
Working on it.
Add all cloud hosts as targets.
Working on it.
Can I compose this?
Yes, all required elements are in the catalog.
Execute command compose service.
To do this, I will create a new service called CRM to Cloud Host ETL Pipeline. Configure the service to use CRMs, SAP and Salesforce, and the customer table from the Snowflake database. Configure to use Cloud Host targets, Azure, AWS and GCP. Configure the service ETL transformations between CRM and Cloud Host catalogs. Configure the service to perform transformations between CRM orders and Cloud Host inventories. And configure the service to display logs and orders in the connected customer portal. Would you like me to proceed?
Yes.
Okay, working on it.
Okay, so the system went through the catalog and not only picked out the sources and targets that were needed here and had a lower level idea of what the ETL objects are, and it's displaying them to me here. It composed them into a simple service graph, but what it did was, in addition to those services, it also needed to use some of our GenAI building blocks, basically our platform services. So it needed to be a transformation engine and a scheduler, and it even attached a portal. And I can go into the configurations of any of these, and you'll see they become pretty rich. I can actually define that this will be a bidirectional relationship because the APIs support it. At the scheduler level, it was able to determine these things will support real time instead of batch, but of course I can configure this to do whatever the process is going to be needed that's required. So in this case, it generated and implemented all of the interfaces. And then we talked about how it was going to generate an ETL pipeline as well. And this is similar for any kind of process, right? It just happens to be ETL here. But what we're looking at is a high-level state chart. It's just how we do process, which is basically a very dynamic way of being able to take high-level tasks and contextualize them for purpose, right? So basically, I don't have to describe what the integration steps are going to be for AWS or even what version of it I'm using. It will figure out what those bindings are in real time for me. I'm basically describing, though, in the system a high-level data flow, and I can look at this as a simulation if I want and see how this thing would actually play out. And if you have time, you go into the details here, but it's all nicely described. But basically what we're doing is listening on all endpoints in parallel. If any change happens to any one of them, we can kind of see that, okay, well, our change is going to be reflected in parallel again off all of the other objects. And basically what we get is this kind of many-to-many pipeline that I really didn't have to do anything to design at all. I just talked to the system and it was able to generate this entire flow for me in application. I'm going to put it through testing now, just like we do with anything else in Enterprise Web. And then within a few seconds from now, I'll be able to launch the service and it'll be live. It'll be doing the exact process that we talked about there and that was described in the system. And it's going to be doing it massively parallel. So this will support, 10 records, 10,000 records, whatever you have, as long as you have basically the resources to scale
The
out.
service has been published to the
We'll be able
catalog.
to support that in parallel. So it's published now. So I'm just going to show you now the result, right? It's in our catalog. We can pop into it. We have all kinds of nice things about case management and so on surrounding these, security and so on. But what I can see is the state of my service is running. And if I look at the log, I'll see that in under 2 seconds, what we have here is actually, the service was started, wound up, detected products across things like Azure, mapped them to lower level IDs and basically elements in ERP catalogs, and it synced all those catalogs in real time. That was a process I made in, under 10 minutes for onboarding and deployment. And that's basically typical of how you can get up and running very fast. And, it makes it a very easy and nice place to do development. Okay, back to you, Dave.
Okay, great. So I'll share my screen again. So that was the first demo, and we got one more for you. It'll be code support. That'll go faster. I was supposed to have shown you this slide last time. It would have been maybe made that demo scenario, but you saw what you saw was Bill was connected enterprise systems and cloud-based apps going through Enterprise Web, and Enterprise Web was essentially incorporating the LLM, its capabilities to sort of support the end-to-end software development lifecycle there. So this time we're actually going to do more on code support, more for the developer here, and we're going to actually show how we can use GenAI to essentially enhance GenAI-based code support. For those of you who've been working with it, GenAI, the more the complex the task, the worse GenAI performs, the less reliable it is. We're working with one of the largest North American Tier 1 telecoms right now, who's already deploying our system in production. And they tested every combination of LLMs and different tools and said Enterprise Web by far has the best quality and performance of any solution for code support. Because beside some of the reporting on Gen AI is somewhat delusional when they give those scores on LLMs and it's like 95%, 96%, whatever it is. Those aren't actually scores of deterministic accuracy. LLMs are not deterministic; they're probabilistic, and they're not 96% probabilistically reliable either. When they give you a score of like 96%, it's sort of like subjectively, yeah, that's a reasonable response. But when you're talking about like automation systems, and you're talking about like the syntax of code, and a reasonable response, it might not be good enough, right? And so Enterprise Web uses its graph, its understanding of code, its understanding of distributed systems to ground LLM outputs in our domain knowledge, so that we can optimize those LLM outputs and improve the experience for software developers. So we're going to simplify and automate the training. So we're always trying to reduce the amount of LLM interactions. So we essentially reduce graph rag to, and sort of the document support to like a push button, right? You have some code samples, you got some logs, push button. The system takes care of it. It all goes through Enterprise Web. Enterprise Web, all the documents go through Enterprise Web's graph. They all get tagged up. And then we just give to the LLM those things on a contextual basis per interaction that the LLM needs to optimize that response. So we're doing the least amount of no training, the least amount of tuning, and we're minimizing prompts and tokens. So we can have a very efficient, we're going to want to lower the costs, we want to lower the latency, we want to optimize the results of that LLM. So essentially we're using Enterprise Web for an intelligent graph rag orchestration as a platform-based workflow as opposed to a static pipeline like LangChain or LangFlow or something like that, which is manually statically coded pipeline with encoded Python. None of that's enterprise grade, right? None of that's going to scale. Like Python is notoriously slow and non-performant, so that stuff's not going to scale. It's not, you're not going to trying to put governance over the top of that. It's going to be horrible. So again, it's leveraging enterprise web's knowledge graph for the software domain. We're already demonstrating in this use case code support, static and dynamic runtime analysis. So we're talking about live analysis. As the developer's coding, the system is going to be updating in real time going back and forth with the LLM. So our speeds with the LLM are millisecond speed responses because we're so targeted. When people do a lot of the graph rag that people are doing, essentially they're thinking that data is the most important thing, but essentially that's a blunt instrument. That's like carpet bombing the LLM. What you really want to use is context, right? You want to give very refined domain context to the LLM, which is more like precision munitions, right? It's more like a cruise missile than a carpet bomb, right? Because your goal is not just to dump your garbage can onto the LLM of data. Your goal is always just to optimize that interaction and optimize that output. So I'll stop sharing, Bill, and you take it away again.
Thank you. Okay, can you see my screen?
I think it's coming up. There it goes. So
Okay,
last time we showed you how Bill could talk to the system and move through the UI. Now Bill's going to be, and notice that they synced. Bill could actually go through the UI and talk to the system, and the graph was maintaining a session state. And of course, we have no long running sessions. We have no long running threads. Everything is async. So we're using durable memory and transaction memory to manage, to persist the state of his session. Essentially a virtualized session. But now we're going to show you how GenAI can work through the API as well. So Enterprise Web can run headless under a customer's own portal, which for a lot of enterprises would be the natural way we would work. So go ahead, Bill.
Yeah, thanks. So I'm going to play the role of a developer. I'm just going to show you how this code support can help me in my day-to-day life. A typical problem that you get in coding is someone hands you a project you've never seen before. In this case, they might give you a Git repo, etc. You're looking at something like a Tomcat application. In this case, it's implemented in Ansible. So you load it into your IDE. You look at things like the README file, and you find out that basically the documentation, all it tells you is this thing deploys a Tomcat server. It might as well just be the title. If I look for actual support on the code itself, trying to understand it, if I pop into any particular file, there's nothing. I'm basically reliant on whatever the developer decided to do in terms of comments. What I'd like to do is obviously a lot better, right? So what I can do is I can point our system at this, right? So I'm going to just show you a quick little API call here. This is headless, but basically I'm pointing it at that little bit of code that we're working with. I'm just identifying that I'm going to be working in the Visual Studio Code element, and I can turn on and off a bunch of features. I want summaries. I want
so this demo is running in Azure, and we just published it in the marketplace. We're direct partners of Microsoft.
Yep. So I activate a set of features here, and what I'm going to do is just turn this on. What you're going to see over here on the left is actually going to be that the system generated a set of recommendations. This little MD file here popped in place, and what I can do is I can look at it. Let's just preview it so it's a little bit nicer to look at. And what I'll see is what the system gave me basically right out of the box, right? So as it started monitoring whatever was inside of these files, it passed them through the LLM, passed them back through us and all those filters. Basically, what it gave me was a much better code summary than what you saw there. Instead of that one paragraph, I've got something that tells me this is divided into 3 sections. You can see it's very detailed. It's going to give me a really good idea of what that code is that I just inherited. Then I go further and I see suggestions for improvements. I see literally a laundry list here that comes out of things I could change to make my code better. And then I start to get into things that are even more directly useful, right? Not just like as much as that is useful for me as a developer. Things like deprecated code, though, I'm taking code that was old. It's telling me literally somewhere inside of my code, there's a pseudo, like basically it's validating best practices. I need to fix this really to make my code sort of compliant for the modern world. So let's go and fix that, right? So I can go into my task here. Oh, sorry, it was, which one did it give me here? Tomcat tasks, oh, sorry, it was here. So I'll make my changes. So I'll get rid of those pseudo lines that it told me, right? Save. And then when I come back to my recommendations, what we'll find is that it actually updates, and in real time here, let's go back to our recommendations. what I'll see is that that's gone, right? No deprecated code is found anymore. Then there's an anomaly warning. So it's actually telling, this is even going further. So this is the dynamic analysis, actually based on logs that we have, right? It's comparing it to the fact that if I changed a web server, I might get 22.6% better latency, right? So it literally is directing me to make changes in my code that are going to make it better, right? So if I come in and I change this to web server 2, I come back to my recommendations, you can see it's already updated, right? So this is all going to be in real time. It's going to be monitoring what I'm doing here, and it can push these recommendations into any engine. It's headless, so here it just happens to be into Visual Studio, but I can basically attach this to any code I'm working with across different languages. This happens to be Ansible here, but Python or whatever you want to work in, and it will basically be my sort of partner like a Copilot really should be, without me having to prompt it or do anything else like that. I just activate a set of features and I get them for free. So,
hey guys, I want to leave time for questions, and we're running up on a couple of minutes. So, does anybody?
That's it. We're done.
All right, well, let's get timing then. I didn't want to be rude, but I want to make sure we got time per question. Couple questions. Does anybody have questions out there?
Comment. It's awesome. That connects so many dots that I've been trying to connect. But I mean, you're putting into practice stuff that I suspected would be useful, and to see it running it was very impressive. I'll have to think about what questions I would ask, but I'll save that. The whole graph of the enterprise concept is feels very right to me. And the older the enterprise, the less digital the enterprise, the older the company, the digital transformation effort of that company, this is mandatory. and nobody knows that yet.
Yeah, it's and the thing is, it's an abstraction, right? You can take that abstraction as far as you'd like. So you can, what's a nice thing about doing it the way that we've done it in Graph is that you could actually say, let's take a small indicative use case that's problematic for the enterprise, and you could start there, right? And you could actually say, this is the scope of for a quick POC or trial, whatever it is. But since it's Graph, it's not like it's building rigid hierarchical structures, right? You can just say, okay, let's extend it further. Now let's include these systems. Now let's include these systems. So it's really ideal for grow as you go, right? You don't actually have to like boil the ocean in a single day.
I totally get it. Yeah. Absolutely. And it's the enterprise full stack nature of it. It's not just the graph, it's the full stack.
You're right. That's actually the more disruptive part of it, right? Because the stack is the enemy ultimately of enterprise agility, right? It's all these manually coded stacks with manually coded integrations that just kill all interoperability and end-to-end automation.
Yeah.
Right.
We could talk for days. I'll shut up.
I would actually like that. It depends on the location. Let's get a good location for that.
Yeah, it's a great product. Been very, very impressive. Completely agree with Paul. One small question.
Yep.
So, when we do all this real-time integrations, there is always a layer of translation, and in case of ETL, people call it as transformation, which is really, really complex. And that is where the challenges come in. Instead of this point-to-point integration, that does this product, I know we don't have to kind of go into demo, but does this cover a level of transformation, translation of data between source and target?
Yes, that's exactly what it's doing, and it's doing it in a really sophisticated way, right? At high speed, right? So you can imagine in just using these telco workloads, because the telcos actually have a superset of distributed systems problems because they have to deliver the network too. So you can imagine that we're actually standing up mobile networks where we're taking a set of heterogeneous functions across heterogeneous diverse environments, and we actually have to, with no manual code, we're saying connect this Cisco router to these 5 functions deployed on this radio access network, and the system computes the sum of all requirements and constraints for all the participating elements and late binds everything itself with no manual intervention, right? And that's really the magic trick that you sort of between you, Paul, and Dave, you got to it. It's that ability to take these things that would be really complex and time consuming and tedious for developers to do one off and say, gosh, we can model these things at a higher level in an upper ontology, and we can just understand these kind of connections, and then we'll use the specifics of whether it's a Cisco router or a Juniper router or a Sienna router, right? One might have a CLI with specific requirements and some interfaces for the native AWS interface services are different than the Azure services, but that's okay. We can generalize all of that. And then when we see, okay, this one's going to AWS, use the AWS policies, use the AWS interfaces. When it's going to GCP, use the GCP interfaces, and so on. For every participating element, it's going to be mindful of the requirements and constraints of that element. Did that make sense, Dave?
Yeah, thank you.